Okay, so chapter 3, lecture 3, calculation, and order, or the order of operation. And we'll also be talking about ordering numbers. So the previous lecture, we learned about the symbols already. Equal to, more than or equal to, less than or equal to, less than, or it's more than. Okay, and we also have not equal to. For example, 2 is not equal to 3. That's all. That's the notation. And now let's say that we have a value x, and let's say x can represent anything, but we don't know what's the value of x. But we know for sure that x is more than 3. So we could use a number line. Let's say 3 is here. So 3 is here. X is more than 3, so we could start. So since x is more than 3, x could be 3.000001, 3.00000001, and so on, right? Or it could be 3.2, 3.1, doesn't really matter. But it cannot be equal to 3. It just has to be more than 3 by maybe a very small number. That will also work, or it could be this. It will also satisfy the condition that is more than 3. It just, when you subtract them, you can't have a negative number. It has to be positive. So since 3 is here, but we do not want to include that. So we put a ball, it's kind of like an empty spot, and we draw an arrow. Say that, hey, it could be 4, it could be 5, it could be 6, it could be 3.5, could be 3.0001, anything. Okay, we can represent it on a number line using this. If it were to be, let's say, more than or equal to, then we change the notation to this. Notice that in the inside is not empty. Okay, I color code it. Just represent more than or equal to. So this represent more than. If it's this, represent that more than or equal to. Let's say that I want to represent certain inequalities. Inequalities means, well, not equal, like example notation more than, less than, equal to. So let's say I have a value of x more than or equal to -2, then draw a number line. Let's say -2 is here, it's more than, so more than or equal to, right? But since more than or equal to, I color code it because it can also be equal to 2. If it's not more than or equal to, if it's just more than, then I don't color code the inside part of the ball. I just leave it empty. But this is just one inequality. Let's say I have another inequality as well. Let's say this is a number line. Zero is here, 1 is here, 2 is here, 3 is here, maybe 1 is here, maybe 2 is here. Now, let's say I have x, I have some value x, it's less than 0, but x also has to be more than x has to be um, more than 3. More than 3. So I could represent it using this notation. It's more than 3, so this condition is satisfied. But x also has to be lower than 0, so this notation, and it has to be less than that. Less than that. So it's starting from here, but not include 0. Here, not include 0. Anything less than or more than that would satisfy the condition. Okay, so over here does not satisfy the condition. You could represent it using this number line. And for the sake of saving space, I could write these two as let's say 1. So in just one statement. So x is less than 0 and 3 is less than x. So I could read it this way. X is more than 3 is the same as 3 is less than x. Okay, I put the x here in the middle, like over here in the middle. This can also be read as x is less than 0 here. It's less than 0, but x is also more than 3. So I could put these two into just one statement. It's an easier way to write things down. Now, let's talk about the order of operation. Let's say we have this value here. 2 plus 3 times 4 times 4 subtract 2 and it's, yeah, this would be the case. So what's the answer to this one? If you ask, let's say person A, the person A computed this thing in a way that, hey, he goes from left to right, this to that. So what he did first is 2 plus 3, you get 2 plus 3, step 1, 2 plus 3, you get 5, and he multiplied by 4, and then you get 20, right? 2. Six multiplied by 4, you get 24, and he subtract by 2, and the answer you got is 22. But then the person B, he does it this way. So he says that, hey, I want to go from right to left. So that's what he did. 4 subtract 2, you get 2, and then multiply by 3. Multiply by 3, you get 6. You add 2, and then it's 8. And the other person C, he does it this way. He multiply it first by 12, then 2, 3 here, step 2. it doesn't matter how you do the operation now. Subtract 2, get 2, get 12 as the answer. So as you can see that all the answers are different. So who is actually correct? Well, this person is correct and these two are wrong because they're not performing the order of operation in the way it's supposed to be done. The thing is, it's not entirely wrong per se. It's just back then people did it very differently, so it caused a lot of troubles, and they were not able to agree on what the answer is. So they came up with this standard standard order of operation. In which order should you do the operation, so we could all get the same answer. So the operation, so the operand states that you should do something that's in brackets first. So working from inside out, okay, and then something that's raised to power, like indices, like maybe x raised to 2, something like that, and then division, and then division and multiplication together, but you should do from left to right, and then addition and subtraction. Doesn't matter which order you do addition and subtraction. It just, because subtraction is essentially addition in its own way. It's just that you have a negation symbol in front of it, like 2 and -2. You can write -2 plus 2 and you still get 0. Okay. So let's say I have this. Let's say I have this 12 divided by 4 subtract 2, then plus 6. Okay, if I would do from this side to that, get 12 divided by 4, subtract 2 plus 6, and then this should be 3, subtract 2 plus 6, then you get 7. It's answer. Do whatever is the bracket first. If, let's say, it's is given this way, okay, parentheses here, so we should do what's inside here first, okay? So for this one, you get 12 divided by 2, and then plus 6, 12 divided by 2, you get 6, then plus by 6, get 12. Okay. Now, another one, say 12 divided by 4 multiplied by 5. Since division and multiplication are done together, but we have to do from left to right. So this is how you work it out. This get 3 times 5, get 15. Okay. But if there were a bracket, then you work this one out first. So it's 12 divided by 20. So it'd be 6 over 10. And 3 over 2. Oh wait, my bad. 3 over 5. So that's the order of operation. Let me give you another one. Let's say that 4 square minus 6 divided by 2 times 25. So the brackets here. Oh, wait. Plus 7 square. So we do what's inside the bracket first. So 4 square minus 6 plus 7 square is 6 plus 49. Could write this as 16. And this 49 plus 6, I get 55. 16 minus 55 divided by 5. This I would get 39. 39 over 50. And that's how you do the order of operation. Brackets, in brackets, indices, and division, multiplication, addition, subtraction. And don't worry about indices, you'll be learning about it a lot more to understand it. Okay, last example. 18 divided by 2 divided by 5, subtract 2. So we do it in this order. 18 divided by 2. Nine divided by 3, which is 3. And so just want to put it out there that this 12 plus 3 times 3 12 plus 3 times 3, 12 plus 3 times 3 plus 2 divided by 8. 8 divided by 2 is not the same as 12 plus 3 times 3 plus 8 divided by 2, because over here we have to do the order operation, no brackets, multiplication and division here from left to right. I get 12 plus 9 plus 4. So I get 25 here. But whereas over here, I'll do whatever it's in the brackets first. So this will be 15. And times by 3 plus by 8 divided by 2, right? So it's multiply and division. Here we do from left to right. So this one first, 15 times 3, I get 45. This with that, I get 4. So 45 plus 4, I get 49. Okay. And that would conclude the lecture for chapter 3, calculation and order. So the key takeaway for this chapter is the order of operation. Okay. Order of operation, which are these, and could be written as a mnemonic for it, and the mnemonic is bit as dm for division multiplication, A is for addition and subtraction, B for brackets, or I for indices. Or sometimes you might see it as what must. The difference is here, I and O. I stands for indices, O stands for, I don't remember what it's called. I think it's operational order or something. Okay, and that would conclude everything.